Chimneys triggered undetectable structural fires. Chimneys were embedded fire hazards. Built from unsealed stone, cracked clay, or timber packed with mud, they absorbed heat and transferred it directly into cabin frames. Every fire cycle dehydrated structural beams behind the hearth until the ignition threshold was silently breached. Creosote caused the flue within days. It thickened into a volatile fuel column. Without scrapers or clean-out ports, pressure escalated inside the shaft. A flare-up triggered a vertical flashover. Superheated gases launched burning debris into the roof cavity. Walls lacked fire separation. Support beams were fully exposed to thermal spread. Heat advanced into the attic space and ignited internal loft timbers. Collapse began above the living area before visible smoke escaped. Chimneys weren't ventilation systems. They were vertical ignition zones engineered into the structure itself. Combustion started silently. Survival was unlikely. Cooking zones caused downward ignition. Cooking areas were built without thermal shielding. Cast iron stoves sat on raw floorboards. Open flame was applied directly to wood, with heat radiating downward into support beams. Daily exposure dried subfloor timbers until combustion occurred beneath the occupants' feet. Grease and fat vaporized under extreme heat. Vapors accumulated around the stove, forming an airborne fuel layer. Spillover from pans ignited instantly, sending fire across the cooking surface and into wall seams. Grease ignited more than food. Floor cavities collected dry debris, rodent nesting, and ash buildup. These zones became hidden ignition beds. Heat from stoves penetrated the upper floor, lighting fuel below the surface. Collapse began underneath before any fire appeared above. Cooking stations lacked fireproof containment. Each meal activated a potential collapse zone, pressurized with accelerants, soaked in radiant heat, and structurally exposed from below. Oil lamps turned living rooms into blast zones. Oil lamps on the frontier were unstable fuel chambers under constant heat strain. Flame sat inches from liquid kerosene, sealed in thin glass or warped metal. Repeated heating triggered thermal rupture. Pressurized oil escaped through microfractures and ignited on contact with walls, bedding, or skin. Kerosene vapor pooled across ceilings and enclosed corners. After refilling, lighting the wick often sparked vapor ignition. Flashover ignited the air itself, climbing into rafters before the lamp left the user's hand. Wicks were hand-trimmed and poorly regulated. Overfed flames stretched upward, contacting roof beams, fabric partitions, or loft joists. The failure began during normal use, in kitchens, bedrooms, and storage cabins. Oil lamps weren't light sources. They were open-flame pressure vessels primed to detonate in confined airspace. Roof fires started from above, not below. Frontier roofs were built from dry cedar shakes, pine boards, and bark shingles, materials with low ignition thresholds and high flame spread rates. Heat didn't rise into them, it started inside them. Sparks from chimneys, stovepipes, or wind-blown embers landed on dry rooftops and ignited within minutes. Once flame entered the roof layer, fire spread laterally beneath the surface. There were no fire stops, no ceiling tar, no thermal baffles. The roof became a horizontal fuel path, feeding combustion from one end of the cabin to the other before smoke ever reached ground level. Collapses began from overhead. Rafters failed in sequence. Burning shingles dropped into lofts and onto bedding, activating multiple ignition points at once. Residents looked up, then had seconds to escape. The roof wasn't protected. It was a preloaded combustion lid exposed to open flame, wind-borne ignition, and total structural failure from the top down. Lightning ignited cabins from direct strikes. Frontier cabins stood isolated in open terrain, with no grounding rods, no conductors, and no atmospheric discharge paths. During storms, lightning struck directly into rooftops, splitting beams and igniting interiors in seconds. Dry pine, cedar, and bark-roofed cabins offered zero resistance to the electrical surge. The strike didn't just start a fire, it exploded through the structure. Superheated air vaporized moisture inside support posts, causing instant structural cracking. Rafters splintered under thermal shock. The ignition zone spread outward from the impact point at ceiling level. Many cabins burned before the storm even cleared. With no insulation, no containment, and no separation between roof and living space, combustion moved downward, fast. Lightning didn't need kindling. It turned rooftops into ignition sites and walls into fuel within seconds of contact. Wall cavities functioned as fire conduits. Frontier walls were constructed from stacked logs, chinked with dried mud, moss, or straw. These materials trapped heat, held embers, and formed internal air gaps. Once flame entered a cavity. Through a cracked flue, a cooking flare, it traveled unseen. Walls lacked thermal barriers. Heat moved laterally between log seams and upward through gaps behind paneling. Dried organic chinking served as a continuous fuel path. Fires inside the wall burned silently, bypassing detection until the ceiling or loft caught. By the time flame breached the interior, the wall frame had already failed. Load-bearing logs ignited from within. Collapse began as a structural chain reaction. Walls weren't barriers. They were horizontal burn channels loaded with hidden fuel and zero containment. Stored fuel caused full structure detonations. Frontier cabins contained high volatility materials stacked in confined, heat-exposed spaces. Black powder, kerosene, turpentine, lard, and resin were stored beneath beds, above cooking zones. Containers expanded under ambient heat until rupture pressure was reached. One thermal breach triggered chain reaction ignition across multiple surfaces. Black powder detonated in confined air. Shock waves fractured wall seams and dislodged support beams. Kerosene vapor ignited mid-air, creating simultaneous flame vectors that spread in all directions. Combustion began at multiple points, floor, loft, walls, within seconds of ignition. These materials weren't isolated. Fuel loads were embedded into daily living zones without containment or thermal shielding. Once the first accelerant was compromised, secondary sources ignited automatically. Stored fuel didn't feed fires. It initiated full structure failure through blast pressure ignition and total internal flame spread. Wind accelerated fire spread through open structures. Frontier cabins were built without internal seals, fire stops, or compartmental divisions. Gaps between logs, open doorways, and exposed roof seams allowed airflow to pass directly through living spaces. When fire ignited, roof, wall, or floor, wind accelerated combustion across the entire structure in minutes. Airflow increased flame velocity. Fires that began in a single corner advanced through wall cavities and rafters under constant oxygen feed. Wind forced flames into upper lofts, down stairwells, and across open thresholds. The fire didn't spread. It was pushed. High winds lifted burning debris from one cabin to another. Wind didn't just support fires. It turned one ignition point into a chain-burning system that wiped out entire homesteads. Nighttime fires eliminated reaction time. Cabins burned fastest when occupants were asleep. Fires that started after dark advanced undetected, through walls, lofts, and floorboards, while families lay inside. By the time smoke or heat reached sleeping areas, the structure was already failing. Flame visibility was limited. By night, there was no external light source, no early visual warning. Fire advanced silently behind timber walls. Rafters collapsed from overhead. Floorboards ignited from below. Escape paths, doors, ladders were cut off before occupants woke. Interior fires progressed vertically and laterally without resistance. Without artificial lighting, firefighting tools, or structural insulation, there was no containment. Only combustion in total darkness. Night didn't slow the fire. It only delayed awareness, long enough to trap everyone inside.